Hey guys, we're here to talk about quadratic inequalities, which are just parabolas, parabolas with less than or equal to. I'm sorry, I have that backwards. Greater than or equal to, less than or equal to. So in our first example, we have x squared minus x minus 12 is greater than or equal to 0. The book gave us two different methods to work on this one. The first method is obviously going to be the algebraic one because that's how they are. Apparently, if you can't solve stuff with algebra, you just can't solve math. So on method one, we're just going to set this exact same question up and solve it like it has an equal sign in it. And I'll explain why later. And this actually is going to have some useful value to you here when we start talking about things that have more than more than two x-intercepts. So here we go. So how would you solve this equation when it was equal to 0 like that? Um, what I would do here is factor it. And again, apparently if you can't factor, you can't do advanced math. The leading coefficient is 1, so I think we would be able to use the diamond-only poster right straight above here. And two numbers have multiplied to negative 12, multiply to negative 12, add to negative 1 are going to be negative 4 and 3. So we're going to have our two factors, and we can set each one equal to 0, which means we're going to have x equals 4 and x equals negative 3. Now, when we were in advanced algebra, we did a question a little bit like this where we had two parabolas stacked above them. I want you to think about these things on a number line, okay? And we're going to put our zeros. It can be kind of just a generic number line, zeros of the function at x equals negative 3 and x equals positive 4. It really doesn't matter where you put them. And what we're trying to figure out in this problem is where is it that those answers are going to be positive, greater than or equal to 0. So this is going to be kind of an important little tool, this number line with these tests on here. So we're going to test some points, something to the left of negative 3, something in between negative 3 and 4, and something to the right of 4. So I just pick whatever's easy, stuff that I can do in my head. Now I go back to the factored form, back to this part right here. And look at that. If I put negative 4 in for x, I'm going to have negative 4 minus 4. And all I really care about is whether it's positive or negative, because that's what the original problem was all about right up here. Is it positive or negative? So if I put negative 4 in for x, what that happened there? All right, negative 4 minus 4, that's a negative 8, that's negative. And if I put a negative 4 over here in for x, negative 4 minus 3 is negative. So I'm going to have a negative times a negative, which is positive. So right there, negative times a negative is positive. Then I do the same thing with my next test point. So again, I'm going back here to the factored form. And if I put 0 in for x, I'm going to have 0 minus 0 minus 4 will be negative, and 0 plus 3, that'll be positive. So I'll have a negative times a positive, which is negative. And then do the same thing. I like a little more angly pointer. So do the same thing with the 5. If I go with 5 minus 4, that's going to be positive, and 5 plus 3, that's also going to be positive. So I'm going to have a positive times a positive, which is a positive. All right, so remember what the point was, that we are looking for the places where the function is going to be greater than or equal to 0. So where is that going to be? Well, it's going to be over here to the left of negative 3. Remember, our zeros, where it was equal to 0, was negative 3. So to the left of negative 3, and I went with square brackets, right, because it's the or equals to in the original problem. And then I have the union because there's a space in the middle, all right, that is going to start at 4. Again, we're looking at our zeros. It could be 0 at 4, and anything to the right of that is going to be positive. So we had to put the union in the middle. I think when we did this in advanced algebra, we put maybe the word or in the middle. And it's like this. It's like Mr. Bowers thinks that I can be on the phone right now talking to him, or I can be making a video talking to you at the same time. I can't do both. I don't know if you heard my phone go off in the background. I want to give you an alternative to this, which is what the book calls method 2. And we're going to use our graphing calculator. We're going to type these into the graphing calculator. And we're basically looking for the place where is the parabola equal to or above the x-axis. So the parabola is, you know, this part here on the left. Right there is your parabola, and this is your x-axis. So I went over to the graphing calculator and I graphed that baby, and we can go through and figure out where the parabola is above the x-axis. I wanted to show you something in addition to the trace button, which is your favorite. So you can go to Menu, Analyze Graph, and we're looking for the zeros of the function. And it's asking you a question. See on the bottom left, the lower bound. So I can do a click, drag, click. And if you do it this way, it leaves the point on the screen for you. You know, if you were hitting trace, you know, as soon as you left that spot, it wouldn't still be there. So Menu, Analyze Graph, 0, and click, drag, click. And it leaves the points on the graph for you. So now you just have to answer the question that we had over here. Where is the parabola equal to or above the x-axis? And the answer is to the left of -3 and to the right of 4. So that would be these spaces over here. So I would put, because we could be equal to -3 and all the way down to -infinity. And same thing over here. We could be equal to 0 at 4, and that was 4 all the way to positive infinity, and union in the middle. Oops, not, sorry, that style. A little more difficult version of this question, using method 1. Again, we're going to treat it like equals. Since this one has both the x and an x squared in it, we're going to have to, or you're not going to be able to like just throw stuff over the river per se. You're going to have to get this equal to 0 and either factor it or use the quadratic formula. So I'm going to throw everything to the left side, getting it equal to 0. And again, apparently, if you can't factor, you can't do math. Now, this one has this leading coefficient of 3, so we're going to have to use that poster over there, the box and diamond. Remember when we go through and do that, we put the third term in one corner, and we put the first term in one corner, the third term in the other corner, and we multiply them, and our product is -15x squared. The sum, that's your second term, that would be this one here. The sum is going to be -2, looking for numbers that multiply to -15x squared, and add to -2, it's going to be -5x and 3x. And we do all the factor business, and that leaves us with x plus 1 times 5x minus 3 equals 0. And we use the 0 product property, and we find out that x is equal to 1 or x is equal to 5/3. Again, this is that little number line that I think we should try to use. Our zeros were at these 2 points, and we just put those on the number line. Those were our zeros. And we're going to test some different points. So I just picked something to the left of -1, and that was -2. Something in between -1 and 5/3, and something that's to the right of 5/3, which the closest and easiest thing is going to do. Again, we go back to the factored form of that as I do this, and if I put a -2 right there for x, I'm going to have -2 plus 1, that'll be negative. If I put a -2 in for x here. Again, I don't care what the value is. I just know that it's going to be a negative times a negative. That'll be a negative. So, I'm sorry, a negative minus a negative would make that negative. Sorry. So a negative on the first quantity times a negative on the second quantity is going to be a positive. And do the same thing down the line. If I put a 0 in for each of these x's, this first quantity is going to turn out positive. The second quantity is going to turn out negative, and I'll have a positive times a negative, which will be negative. And same thing when I put 2 in, that'll be positive because it'll be a positive 2 plus 1. This is going to be, we might have to do a little bit of math here. 3 times 2 is 6 minus 5, that's positive. So a positive times a positive is a positive. Now remember exactly what we were looking for here in the problem. We were looking for in the original question, where is it less than on this problem. So I go down here, bring my arrow with me, and I'm looking for the places where it is less than 0, which is going to wind up being here in the middle. And since it was less than and not less than or equal to, I go with parentheses in interval notation. So it's the stuff that's between the zeros, not including the zeros. If you do want to check that, you can go to the graphing calculator, and the question is basically, where is this parabola going to be below that line? So I went to the graphing calculator and graphed that for you as well. Took me a second to kind of get my window set up, but I need to figure out where is that parabola below the line. Well, that's going to be in this space. It's kind of right under here. Okay, so I need to go figure out those the intersection points on that. So I went to the calculator, and again, that's why I wanted to show you that analyze feature here. So if you go to menu, analyze graph, and now I'm looking for the intersection. So it's asking me for a lower bound, so I want to go to the left of that intersection point. And now it's asking me for an upper bound. I go to the right of that intersection point, and it even pops up. And now it leaves those on there. So menu, analyze graph, intersection, and I'm trying to find this intersection point, so click, drag, click. So this one left you kind of the decimal version of that. But again, we're looking for the space where it was below, and these are the x intervals. So it's from -1 to 1.67. So that is -1 and 1. Well, that's 1 2/3, right? Which was the 5/3 we had before. Feel free to pause or rewind, whatever you need here, and the homework will be on the next slide here. We are at the end of the section here on chapter 3. So again, we're going to be taking a chance to review from the review exercises, the same drill we've done for the past 2 chapters. And we will schedule the quiz when I get back. Good luck.